Problems on sound waves. Problem 1. The frequency of a source of sound is 100 Hz. How many times does it vibrate in a minute? We know 1 Hz is 1 vibration per second. Vibration or cycle. If that is the case, 100 Hz means 100 vibrations per second. That means in 1 second there are 100 vibrations. Then in 1 minute is 60 seconds. How many vibrations? It will be 100 into 60, which is 6000 vibrations. Problem 2. A sound signal of 128 vibrations per second has a wavelength of 2.7 meters. Calculate the speed with which the wave travels. The given is, we know the frequency. The vibrations per second is nothing but the frequency of the sound signal. So frequency of sound signal F is equal to 128 Hz. Now it has a wavelength of 2.7 meters. So wavelength of this sound signal lambda is 2.7 meters. So we need to calculate the velocity, the speed of the sound wave. So the speed V is equal to, V is defined as the distance travelled by time taken. Here the distance travelled is wavelength lambda and time period. And we know that T is equal to 1 by F. So we can substitute here, we get lambda into, instead of T, if we put 1 by F, 1 by F, which is nothing but lambda into F. So we know what is lambda, which is 2.7 meters, and we know what is F, which is 128 Hz. On multiplication, we get 345.6 meters per second. So the speed is 345.6 meters per second. Problem 3. A person has a hearing range from 20 Hz to 20 kHz. What are the typical wavelength of sound waves in air corresponding to these two frequencies? Speed of sound in air is 344 meters second minus 1. Now we know the person's hearing range and we know the speed of the sound in air. We need to find the wavelength. So what are the given things? The frequency range. The frequency range is 20 Hz to 20 kHz. So we will consider F1 as 20 Hz and F2 as 20 kHz, which is nothing but 20,000 Hz. Now we need to find the wavelengths lambda 1 and lambda 2. Now we know the speed. What is the speed of sound in air? V is common, which is 344 meters second minus 1. Now we know the equation between V, F and lambda. V is equal to F into lambda. So in this case, V is equal to F1 into lambda 1. In this case, V2 is equal to F2 into lambda 2. We need to find lambda 1. So lambda 1 is equal to V by F1. V is 344. F1 is 20. So we will get it as 17.2 meters. Lambda 2 is equal to V by F2, which is nothing but 344 by 20,000. So which will give rise to 0.0172 meters. Therefore, lambda wavelength at 20 Hz frequency is 17.2 meter and lambda at 20 kilohertz frequency is 0.0172 meter. So this shows that when frequency is high and wavelength is small, frequency is low, wavelength is very high. Let's see problem 4. The flash of a gun is seen by a man 3 seconds before the sound is heard. Calculate the distance of the gun from the man. Speed of sound in air is 332 meter per second. So basically what happened in this problem is, the flash of a gun is seen by a man 3 seconds before the sound is heard. This can be rewritten as the sound is heard 3 seconds after the flash of a gun. So if you take a gun, a bullet is fired, so the flash is seen. First, the flash is seen because the light travels at a higher speed than the sound. So the flash is seen first by the man, and then 3 seconds after that, he hears the firing sound. So in this case, T is 3 seconds. So what is given? The same wordings, the flash of a gun is seen by a man 3 seconds before the sound is heard, means he has heard after 3 seconds of flash of the gun. It means, and the speed of sound in air is given, V is 332 meter per second. So we need to find the distance between the gun and the man. So which is V is equal to D by T. So D is V into T. So V here is 332 and T is 3 seconds. So which becomes, on multiplication we'll get it as 996 meters. Means the distance between the gun and the man. Is 996 meters. Problem 5. Longitudinal waves travel in a coiled spring at a rate of 4 meters per second. The distance between two consecutive compressions is 20 centimeters. Find wavelength and frequency. So what is given? He says the distance between two consecutive compressions. What is distance between two consecutive compressions? See, if we draw a sound wave, this is a compression, this is a compression, and the distance between the two consecutive compressions is nothing but wavelength. So we know the wavelength. Distance between two consecutive compressions is nothing but lambda wavelength, which is given as 20 centimeters or 20 by 100, which is 0.2 meter. Now the frequency, how do we find the frequency? Frequency of this wave is V by lambda, the speed by lambda. Now in this case, speed is given as 4 meter per second and lambda is in meters 0.2 meter. So 40 by 2, which gives rise to 20 Hz. So the frequency is 20 Hz and lambda is 0.2 meter. Problem 6. A device called oscillator is used to send waves along a stretched string. The string is 20 centimeter long and 4 complete waves fit along its length when the oscillator vibrates 30 times per second. For the waves on the string, find A lambda, wavelength, B frequency F, C speed of the sound V. So what is given in this? There is a string. It is a stretched string. It creates vibrations 30 times per second. The string is 20 centimeter long. So we know length of the string. Length of the string is 20 centimeter. And this length of the string fits how many waves? 4 complete waves. That means, so this is 1 wave, this is 2 waves, 3 waves and 4 waves. So it fits in 4 complete waves of the same wavelength. So this 20 centimeter length of the string is nothing but 4 into lambda, because this is lambda, this is lambda. Each of this wavelength is lambda. So 4 into lambda is 20 centimeter. So lambda is 20 by 4, which is 5 centimeter. So the wavelength is 5 centimeter. Next, we need to find the frequency. So in order to find the frequency, what we have the information is the oscillator vibrates at 30 times per second. That means for one wave, it is 30 times per second. But there are 4 waves in this length of string. So in the length of string, when there are 4 waves, so it becomes 4 into F. So we know for one wave, F is, frequency is 30 Hz. For 4 waves, it becomes 4F, which is 4 into 30, which is 120 Hz. So the frequency is 120 Hz. Now the speed. What is speed? V is F into lambda. Since we are finding speed is F for, here the frequency is, since we are finding for the spring, on the spring there are 4 waves. So the frequency becomes 120 for the 4 waves into lambda is 5 by 100. In terms of meters, we need to convert. So on cancellations, we will get it as 6 meters per second. Hence, we found for the 4 waves and individual wavelength, which is 5 centimeter, and the frequency within the spring for the 4 waves 120 Hz, and speed is 6 meter per second.